All right, here's your joke of the day. Did you ever hear about the mathematician that was afraid of negative numbers? He would stop at nothing to avoid them. That's a knee slapper. So far, if we're talking about the interior angles of polygons, we really only know about the triangle. So if we're filling out our chart here, we know that the triangle has 3 sides. Oh, that's kind of thin. Let me get a thicker marker. It's got 3 sides. The number of triangles in a triangle obviously is just 1. And we know that the sum of the measures of the interior angles is 180. But then to look at the other ones, we're going to see a pattern here with when we have more sides than just 3. The directions here say that we're dividing each shape into triangles by drawing segments from vertex to vertex and to not let the segments overlap. So what it's talking about for the quadrilateral would be drawing this segment from vertex to vertex that would split it into 2 triangles. For the pentagon, again, vertex to vertex, but we'll have 2 of them, so there are 3 triangles there. And our segments can't overlap. It doesn't really matter which vertex you start with, as long as all of the segments come from that one. And there are other ways to split them up that still work, but we can't have those segments overlap, and each of the angles in those triangles have to be angles of the pentagon or hexagon, so on. So with our quadrilateral, it's got 4 sides. Whenever we split it, it's split into 2 triangles. So if we're thinking about the number or the sum of the measures of the interior angles, I know that there are 180 degrees in this triangle, and there are also 180 degrees in this triangle. So if I'm wanting the sum of my 2 triangles, I would multiply 2 times 180, and we get 360. So the angles in any quadrilateral, if it has 4 sides, those angles have to add up to 360 degrees. So then going on with my pentagon, it's got 5 sides, it created 3 triangles. Each of those triangles had 180 degrees in them. So if I have 3 times 180, we end up with 540. And we've got our hexagon. It's got 4 triangles. So our 4 times 180 is going to be 720. Sorry, that noise is my dog eating in the background. And then our last one is the n-gon. So we're just talking about any number of sides. So this could be, heptagon having 7 sides, or it could be a 20-gon. But if it has n sides, that means that the number of sides is n. And notice here, no matter how many sides it had, it always had 2 less triangles. So if I had 6 sides, I had 4 triangles. So if I have n sides, that means I have n minus 2 triangles. So since the sum of our interior angle measures relies on how many triangles there are for that n minus 2 number of triangles, I would have my n minus 2 times 180. So no matter how many sides the polygon has, I can always plug in the number of sides, subtract 2, and multiply times 180, and that would tell me the sum of the interior. So if you had a 20-gon, you'd have 20 minus 2 times 180, so an 18 times 180. That's a lot of degrees. So the larger that our polygon is, it can really have an infinite amount of degrees. If we had 2,000 sides, that's going to be a lot of degrees on the interior. The exterior angles work differently, and for this side you are going to need a protractor. So before you get started, make sure you have a protractor. If you need to, pause the video and get a protractor before you get going here. So for each of these, we are looking at exterior angles. Remember that an exterior angle is formed by extending one side to create that angle. So if we're looking at the triangle here, if I'm trying to create an exterior angle to this right vertex, I can either extend the side at the top or I can extend the side on the right. It doesn't matter which one, but I'm only extending one. and creating this angle right here. So that guy. So that would be one exterior angle. And then again, my vertex at the bottom, I'm either extending my side on the right or my side on the left. Make sure you go far enough that you're going to be able to measure this with your protractor. So you're going to have to go pretty far when you extend. And then my last one, I can either extend, this one's not going to be able to be as long because I'm going to run out of room, but I can extend this side on the left or this side on the top. So I've got this angle here. So depending on what side you extended, your angle might either be on this side or this side. You know, you've got two different options, but it should be the same measure no matter where it's at. Okay, so now you're going to take your protractor and estimate the measure of each of those angles. Remember with your protractor that you are lining it up where you've got the vertex in that little hole, and then we're lining up one side of our angle with that little horizontal segment. And then for some of these you're going to be estimating pretty heavily because it won't actually cross, like in this situation. I'm just estimating where I think that's going to cross at. Again, use your judgment on whether it's acute or obtuse to make sure you're looking at the right angles or the right numbers. It looks like this one's about 144. And you may not decide exactly what I'm putting. That's okay. There's going to be some human error here, but you should be pretty close. This one's obtuse as well. And it looks like about, I don't know, 143. And the last one, this one is acute, and it looks like it's about 73. Turn it back around. I got one of them upside down. So then with the calculator, go ahead and calculate the sum of your exterior angles. So my 144, 143, and 73. Oh, I got exactly 360. Whoa, hello. I can put this at the right angle where you could see it. So I got 360. You may not have gotten exactly 360, but you should have gotten somewhere around there for this. So our sum was 360. Whoa. Now we are looking at what our pattern is, just like for our interior angles. We saw that n minus 2 times 180 was going to work every time. So go ahead and speculate here. What do you think is going to happen with the quadrilateral? Is it going to have a less angle sum for the exterior? Is it going to be greater? Is it going to be the same? We'll see. Okay, so we're going to do the same thing for this one. Now, because of the way that this quadrilateral is created, it is probably easiest to go ahead and extend using the bottom and the top and just extend both sides at the same time. So you're creating your exterior angle here and here. And those do look like they are going to be the same angle. We'll see. And same thing at the top. We can extend both. You don't have to do it that way, but it looks easy to do. Okay, so go ahead and find your angle measures. So for mine, I ended up with 100 degrees for the bottom two angles, 78 for the top two angles. But you may have ended up with something different. It should be somewhere around there though. And make sure you're going through these motions on your own and finding those angle measures, because using a protractor is handy, being able to use a protractor. My sum ended up being 356. So very close to my 360 sum, but it was less than it. We could have some human error there, so we've got one more to go through. Maybe yours was right on 360, maybe yours was the same. Yours may have been a little bit above 360. So let's try one more with the pentagon. Go ahead and pause the video, extend your sides, and find the measure of each of those exterior angles. But pause the video, try this one on your own. All right, after extending those sides and finding all of your exterior angles of the pentagon, might check with mine just to make sure that you're around those numbers. Again, yours won't be exactly like mine, but they should be pretty close to those angle measures. My sum ended up being 362. So maybe yours ended up being greater than 360 or less than 360. It might have been exactly 360, but we're seeing enough evidence here to say that this is kind of interesting. It is always true that for our exterior angles, they always add up to 360. So a little bit of human error on these last two. I got kind of lucky on the first one, I think. But our exterior angles always have a sum of 360, no matter if it has 3 sides or if it has 25 sides, always has a sum of 360. If you think about it, it does kind of make sense because the interior angles, as we have more sides, they're getting larger. They've got to be more obtuse so that they can accommodate 4 more sides. If you can picture what a 20-sided figure would look like, if you want to look up a dodecagon, 20-sided 3D figure is an icosahedron. I don't know, it might be a high 20gon. Anyway, 20 sides. If you can picture that, those interior angles would be really large, so the exterior angles would have to be really small. And so you're adding up 20 very small exterior angles, where for the triangle, all those exterior angles are pretty large, but they're getting smaller. Here, now they're all acute, and if you have enough sides, then they all have to be acute if we have a convex polygon, where it's not caved in on itself. So to sum up what we just discovered, our polygon angle sum theorems, you do not have to know these theorems by name, but we do have to be able to use them. So for the interior angles, we discovered that the sum is n minus 2 times 180, where n is the number of sides. And for the exterior angles, it is always a sum of 360. So don't get tricked by that one. Every time we're talking about exterior angles, the sum is always 360. Okay, so our first example, we're going to be talking about a regular octagon, which remember that that word regular means that all of the sides are congruent and all of the angles are congruent. Or a fancy word for that is that it is equilateral and equiangular. And that's going to be important whenever we're looking at finding one interior angle or one exterior angle, because unless they're all the same, I would need more information to find one of the interior or one of the exterior. But we'll start with interior angles. Now for an octagon, this is where knowing the names of the sided polygons are going to come in handy, that I need to know how many sides it has before I can answer these questions. So an octagon is important that it has 8 sides. And then I can go ahead and use what we found out. So for the sum of the interior, we're using that n minus 2 times 180. So since the octagon has 8 sides, we'll have an 8 minus 2 times 180, which is just 6 times 180. Remember that that 6, that n minus 2, is just how many triangles we can draw with, extending those segments from vertex to vertex. So if you ever forgot your formula, you could come back to this and draw that and see, okay, I have 1, 2, 3, 4, 5, 6 triangles, and each of those triangles have 180 degrees and their interior angles. So I've got 6 times 180. So I can go to my calculator and we will get 1080 degrees. Okay, so for one interior angle, remember I'm talking about an octagon, so it has 8 interior angles. It's got 8 sides and 8 angles. And because I know that it's regular, all of those angles are the same. So once I know the sum of my interior angles, to find one of those interior, I just have to divide by how many there are, because they're all going to be the same. So I've got my 1080 divided by 8, and I get 135 degrees. For the sum of my exterior angles, don't get tricked here, the sum of my exterior is always 360. Yell it, 360. For one exterior angle, We've got a couple of ways to go about this one. One way is to go the same route that we did with the one interior angle, where I know the sum is 360. So I could just divide by how many exterior angles there are. There are 8 interior, so there are 8 exterior. So dividing by 8, we'll get 45 degrees. Okay, but what do you notice about our one exterior angle and our one interior angle? Okay, so maybe you notice that they add up to be 180 degrees, which makes a lot of sense, because remember that our exterior angle is formed by extending a side. So if I extend a side, here's my exterior angle, and here's my interior angle. So what kind of angles are they? They are a linear pair. So if they're a linear pair, that means they have to add up to be 180. So once I know one of them, so I've got 135 for my interior, I could subtract from 180 to find my one exterior angle, and vice versa. Sometimes it's easier to find your one exterior angle than it is to find one interior angle, just because of the type of information that you have. But if you can find one of them, if I can find my exterior angle, I can always subtract from 180 to find my one interior angle. Okay, I want you to try the same 4 questions for a regular dodecagon. Okay, so you're going to be answering the same 4. Now, if you need a hint on what a dodecagon is, if you don't, go ahead and pause the video and try it without hearing from me here. But a dodecagon, before you answer it, you are going to need to know it's got 12 sides. Decagon is 10, dodecagon is 12. Okay, but now go ahead and pause the video. Actually do this. Pause the video and try your sum of interior, 1 interior, sum of exterior, 1 exterior. Did you actually pause it? Pause the video. Try it. Do it. Do it, do it, do it. Okay, so for your sum of interior angles, you should be taking your 12 sides minus 2 times 180. So you should get 1,800. Your one interior, we are dividing that by the number of sides. So you should get 150. The sum of your exterior angles is always 360. Don't let it trick you. And then your one exterior angle, we've got the 2 routes. We could divide by 360 by the number of sides. Or I could take my interior angle, and I know it's supplementary to my exterior angle, so I can subtract from 180. Either way, you get 30 degrees. Okay, so let's look at a few more types of questions that we could be asked with this information. Example 3 says we've got the sum of the interior angles is 900 degrees. We are classifying the polygon by its number of sides. So this is kind of backwards. Instead of giving us the number of sides and asking for the interior angle sum, they're giving us the interior angle sum and asking for the number of sides. So there are a couple of ways that we can do this. I prefer the way where we set it up using an equation because I feel like that is most useful in the future, that we have the ability to set up an equation and solve. So if we're finding the sum of the interior angles, if they found that it was 900, the way that they found that was by taking our n minus 2 times 180. Be careful that you're paying attention to that interior versus exterior, but it was interior. They had to have done this to find that interior angle sum was 900. So this is what our equation could look like to begin with. Now from here we have a few choices. We could go ahead and distribute 180 to the n and to the negative 2. That's fine. Or at this point we could divide both sides by 180. So we're left with an n minus 2 equals 5. And then our last step of adding 2 to both sides, we get that n equals 7. what I want us to be careful of, I always get students that memorize this process, and so they just want to divide by 180 and feel like they don't need to set up an equation. What typically happens with those students is that they stop at 5 and forget to add 2 to both sides. So be very careful. My suggestion would be to actually set up the equation, solve from there. You're a lot less likely to make mistakes if you do that. Now from this, our question was actually to classify the polygon by its number of sides. So if it has 7 sides, maybe this is in your brain bank somewhere, maybe it's not, but we need to be working on it. 7-sided is called a heptagon. A heptagon. All right. Okay, so let's do one more like that. I want you to try this one on your own. What if it has an interior angle sum of 1,440? Go ahead and pause the video and try this one on your own. Okay, so if we set it up the same way, divided by 180, and got that it has 10 sides, which is called a decagon. So you should have gotten decagon. By the way, while we're here, we could distribute that 180 to both sides, so just letting you see another way we could distribute, and then we'd have minus 360 equals our, I didn't have a ton of room for this, 1,440. And then I would add my 360 to both sides. So we would get 180 and equals our 1,800. And then divide both sides by 180. So it doesn't matter if you want to distribute the 180 at the beginning or if you want to divide by 180 and then add 2. Either way, we end up with our n equaling 10. Last 2 questions. Our example 4, we're looking for an interior angle, but in this case, they're not all the same. So I can't just divide by the number of angles. I will have to use the angles that they gave me to know what I'm left with. So if I had something like a triangle and I'm looking at the interior angles, you already know that the angle sum is 180. We will use quadrilaterals enough that you'll know the interior angles of a quadrilateral are 360, the sum, and be able to use that automatically. But if we don't have the interior angle sum memorized, then I need to start with that. So this guy's got 5 sides. So I would start by finding the sum of the angles. We're talking interior here, so I would have that in minus 2 times 180. And there are 5 sides. And sometimes the pentagon is one that we see enough that you will remember it has an angle sum of 540. We see that one quite a bit. But we'd start there, find our interior angle sum, and now we know what these have to add up to. So now I'm setting up my x plus 120 plus 140 plus 80 plus 100 equals 540. Be careful that you don't leave an angle out. That's an easy mistake to make. So in the end, you should have 5 angles because there were 5 angles. And then we're solving for x. So we'll combine all those guys. They are 440 degrees. And then subtracting, we find that x is 100. Okay, so sometimes we need to find that interior angle sum before I can solve for an interior angle. Okay, for example 5, it's talking about exterior angles, and now we've got some expressions here, not just x's going on. We've got a 2x, it's pretty crazy. So for our exterior angle sum, we automatically know, I don't have to calculate anything, that the exterior angle sum equals 360. And then really same concept, we're just saying that those exterior angles have to add up to 360. So I've got my x plus 2x plus 120 all have to equal 360. And then I can solve for x. So we end up with x equaling 80. You can always check it by plugging in your 80. It's not always to scale, but if you had something that was really crazy looking, it looked like it was going to be obtuse, and then you ended up with, 80 as your answer, that something would be off there. So they kind of look like that makes sense, but also adding up our 80, 120, and 160 to see that they do add up to 360. So that is it. You are answering any problem that we've got today using those two things, that the sum of your that the sum of your interior angles are that n minus 2 times 180, and that your exterior angles always have a sum of 360. So everybody just have a great day.